appreciate it. Because yesterday, I don't know where y'all were, but it was... No, you guys were awesome yesterday. You know who it was? It was fourth period. That class, I got to talk with them. I don't know where they were at. But here we go. Density property. Going to solve it here. So the density, actually, let's, before we even get into it, the density property, before we even get into that, we went over this cool stuff yesterday that was, we were talking about real numbers and how to solve real numbers. And before we even started classifying real numbers, we learned about the definition of real numbers, and from there, we learned how to classify real numbers, and then moved on to actually solving for real numbers. I know, I said real numbers a lot there. Kind of like practice. Practice. Okay, back to real numbers. So the next, I'm just going to throw this up on the screen. Remember that screen was all of our real numbers there. But now we'll go over here. If anybody has a question, you'll be able to go back and kind of refresh what each one was here and what they stood for. But we'll talk about the density property over on this side. And the density property says this, guys. It says, hey, if I'm given two numbers, give me the homework problem. Give me one of the problems. Let's look at number 15 here. So number 15 said, find a number that's between 7 and 3/4. Oh, 7 and 3/5. And also 7 and 4/5. So 7 and 4/5. So to do this, the density property says, hey, if I've got two real numbers, hey guys, real quick question. 7 and 3/5, this is really like saying it's 7 with a decimal. So where would that fall on within our real number system? It is rational. Who said that? John, you're getting a treat in a second, and David too. So here's the second question. If it's a rational number, isn't it a real number too? Yeah, so it's absolutely real. And if it's real, that means that there is a number between these. If it's real, what's it telling you? There's a number between these, right? That's what that squiggly line is there. So you guys just tell me. If it's real, then Christine, you're getting a treat. David, you're getting a second one, dude. Great job. Okay, so how do we solve for this? Well, to do that, you need an awesome color first. So let's get yellow. And to solve for this, got to do a couple things. First, I need my number line. That's going in the wrong direction. Yes? Sure. For you, absolutely. Ready? There you are. There's your number line. All right. So here's 0. And now we're going to write 7 and 3/5 here. So this is where I'm just saying it is. Huh? I know. But I'm going over it for those who haven't kind of done it. 7 and 3/5. And 7 and, this is 7 and 4/5, guys, not 7 and 3. 7 and 4/5. So what I'm doing here is plotting these 2 points on the number line. Yes, ma'am, Anna? Yeah, but just here. I'll put it here for you. How about that? Happy? Because you know what? I'm a stickler, and if this was a test, yes, we need to simulate the test. 7, and now that arrow's there. You ready? Moving on from here, what I would say is, hey, there's a number absolutely exactly right here. Right now, I don't know what that number is, but I know it lands smack dab in the middle. Because the density property tells me what, Charlotte? Density property tells me what about real numbers? Okay. Kayla, what's the density property? Tell me about real numbers. Wait, hold that thought. Cameron, Willis, what's the density property? Tell me about real numbers. I've got two real numbers right here, so what's it tell me about real numbers? There's a number smack dab in the middle. There are infinite amounts of numbers here, but there's one exactly in the middle. So Charlotte, tell me, what's the density property? Tell me about real numbers. There's a number in the middle, and these are two real numbers, therefore there's a number in the middle. And the way to solve for it, Kayla says she thinks she knows. I'm going to start it out and see if she can. 7 3/5 plus 7 4/5. What do you think you do, Kayla? Why 2? Why do I divide by 2?
Because there are two numbers.
Yeah, there are two numbers, and actually this is kind of like taking the average of something. If I take the average of something, I'm dividing it by the sum of those numbers. And the sum of those numbers, the average tells me what? What's smack dab in the middle, right? So now, let's go and solve for this. So this actually equals 7 3/5 plus 7 4/5. Well, that equals 14. 7 plus 7 is 14, plus 3/5 over 4, 3/5 plus 4/5 is 7/5. Well, that actually equals 14 plus, guys, what's 7/5 as a mixed fraction? Or mixed number, yeah, it's what? 1 2/5. So 1 plus 14 is? Equals 15. Wait. What did you say? 14 plus 15. Thank you. Equals 15. And now 2/5. Okay. Now, wait a second, guys. How can 15 and 2/5 be in the middle of this? That doesn't make sense. Sean, tell me what's going on. I forgot to divide by 2. So, what I need to do is divide these. I'm just keeping the equation balanced every time, guys. So I'm just drawing in these divide by 2 now. And if I divide this by 2, let's figure out what I get. Does anybody know that solution already? Yes? 7 7/10. Let's find out. I'm going to turn 15 into an incomplete, improper fraction here. So 15 times 5 is what, guys? Huh? 15 times 5? 75? 75 plus 2 is 77 over 5. Okay? Divided by 2, or in fact, let's use its reciprocal. 77 over 5 times 2 over 1. Huh? Thank you. Good save. So it's really 1 over 2 times 1/2. Noah, you're up on the whiteboard. I want you to solve this from here. In fact, you can just turn around and solve it right there. Jordan, I want you to solve it on that side. Yep. It's 77 over 5 times 1/2. No, it's times 1/2. Why am I multiplying by half, guys? Who said that? Who said that? Raise your hand if you just all started that sentence. Who was talking in that sentence? Raise your hand. I heard like 4 different voices talking. Raise your hand. Raise your hand. 1, 2, 3. Got 4, 5, 6. Guys, that is teamwork there. Who had your hand up? Let me. 1. George. David. David, that's 2. Here's a third one for you. 1, 2, Siobhan. We got you here. And I had one for John earlier today. Great job. What's that? You said it? Oh, you had your hand up too? You just guys trying to get candy? Trying to get candy? I did hear your voice. I did not hear your voice.
No,
So let me.
I answered the question.
For 7.7, yes, you did. You did, but I wasn't getting candy for that one. Hey, don't be upset, man. We don't always get candy for doing the right thing. Think I get a paycheck every time I give a right problem to someone?
Yes.
No, that'd be nice, though. I mean, if I got a paycheck for just coming by and giving answers on the test, that's 2. That's 0.4. That's 710. I got like 3 paychecks. I'll be a millionaire by the end of the day. Anyway, back to real life. Keep working. What'd you get? 7 7/10. 7 7/10. Now, great job, guys. Have a seat. Have a seat. 7 7/10 is the final answer. That's how. So the density property tells us that 7 7/10. 7 7. That's for solving it correctly. 7 7/10. Let's put it on our number line. It says, hey, I solved for this equation here with the density property, and the density property told me this value right in between is 7 7/10. Now, guys, here's my point. Because decimals, there are multiple values. I could have 7.7, or I could have 7.71, or 7.72. Guys, you see how there could be millions of billions and infinite amounts of answers, possibilities? But there is only one number that is absolutely in the middle of these two. That's what the density property tells me. Now, this works with, there's one more fact you got to understand here. This works with rational numbers, it works with real numbers, it works with real numbers, works with rational numbers, but the one that it doesn't work out with is when we get to the integers. And since it doesn't work with integers, it won't work with whole numbers. And the reason why is this. What are integers? Are there... Give me an integer, guys. Give me one. Give me one. Huh? -3 is an integer. Give me another one. 1. Give me another one. 3. Give me another one. 5. Give me another one. Who said 6? I heard 6. Okay, look here, guys. If I created my number line here, if this is my number line, and then I have 1. Let's go to 5 here. Let's go to 3, 4, 5. Here's my point with the density property. And 6. Here's what the density property is telling me. It says there's a number. For rational numbers, we deal with decimals. Sure, there are plenty of decimals in between here, but integers don't give us decimals, do they? Integers move from integer 3 to integer 4 to integer 5. Guys, is there an integer between 4 and 5? No. No, because integers don't deal with decimals. So it does not work with, integers. It only works with rational and real numbers. And these are our rational numbers that deal with fraction. These are our real numbers right here. That's the point.